Okay, if you recall from the previous notes, we learned that the area of a function is going to be the top function minus the bottom function. This will give you the height of the rectangle, and then this is the width of the rectangle. So if I integrate the function, you're just adding up all of these rectangles to get the entire area. So now let's look at a couple examples. So the first thing you always want to do is draw yourself a rough picture so you get an idea of what you're looking at. So 2 minus x squared is going to be a parabola that opens down. And then y equals x is just a 45-degree line that looks something like this. So we're looking for the area between these two regions. So this is the region I'm looking at. So I'm trying to find the area of this shaded region that I have. Okay, step one is I need to figure out what my bounds are. So I need to know where these graphs intersect. I can do this without a calculator. We can just set these equal to each other and solve for the point of intersection. I do have an x squared, so I do want to have one side set equal to 0. So I'm going to move the x squared over. I have this, so this is going to be x plus 2 and x minus 1. So x equals -2 is this point of intersection right here. And then this one is x equals 1. Okay, so the idea is if I can find the area of one rectangle inside this region, so here's my rectangle. So notice the area of the rectangle is the height is always the blue minus the red. So the blue would be the parabola minus the red. So this is going to give me the height of this rectangle. The width of this rectangle we call dx, or that's delta x. So I've got the height of the rectangle. This is the width of the rectangle. So this is the area of that one rectangle. But what I want to do is add up all the rectangles from -2 here to +1 to get the entire area of that region. So this is my setup. Okay. Now the integration we're going to just do with the calculator, so just type this into your calculator and double check that you get 4.5. Okay. So let's try the next one, same thing. So I'm going to make a rough sketch real quick. So y equals 0 is just the x-axis. Y equals -2x is a line, slope is -2, so something like this. Again, just a rough sketch. And then x equals 5 is a vertical line. So the region that is bounded by all three of those graphs is this little triangle right here. Okay, now I can find the area of this triangle geometrically, but now the idea is we can use calculus to do it. So what I typically do is I always try to draw in one rectangle and look at that rectangle and do the height of that rectangle. It's always the top of the rectangle minus the bottom. That's the only way you're going to get a positive number. So notice the top of the rectangle hits at this line, which is y equals 0. So 0 minus the bottom of the rectangle always hits the blue line, which is -2x. So 0 minus -2x. That's the height of the rectangle. The width of the rectangle is dx. And I want to add up all the rectangles from here to here to get the entire area. So that would be from 0 to 5. And again, use your calculator and use the calculator to double check that you do get 25 here. Okay, let's try the next one. So x squared plus 2 is this parabola. Y equals -x is a line that goes with the negative slope, goes through 0, 0. And then x equals 0 is here. I'm going to exaggerate this graph. We'll say x equals 1 is here. So notice that this is my shaded region. Okay, again, I would draw myself a rectangle, one rectangle inside that region so you can see what it looks like. Okay, so if I look at that blue rectangle that I drew, notice the top is at the parabola. So that's x squared plus 2. The bottom is this blue line, which is -x. So to find the height of the rectangle, remember, it's always the top minus the bottom. So minus -x gives me plus x. That's the height. The width of the rectangle is dx. And I want to add up all the rectangles from here to here. So I'm going to add them up from 0 to 1. And again, use the calculator for the integration. And go to here. Okay, the next one Okay, this one you are going to use a calculator to look at the graph. Even though you're going to go ahead and use the calculator to look at the graph, I would go ahead and still sketch it by hand just to see what it looks like. And it's easier to figure out what your bounds and things are going to be. So the first one is the cosine graph, this one here. The cosine of 0.3x squared is, if you look at in the calculator of this graph, this is this region. And then this one, the parabola, is going to look something like this. So again, I just made a rough sketch based on what I saw from the calculator, and this is your region. So step one is we need these points. So you're going to find the points of intersection on the calculator. I'm going to store this number as A. It ended up being like negative 1.89 something. And then this number I'm going to call B. It was 1.408 something along those lines. So those will be my bounds. Here's my rectangle. Just draw in a rectangle. So notice the height of the rectangle is always the blue minus the red. So that's the cosine graph minus the red function. Okay, the width of the rectangle is dx, and I need to integrate from A to B. Okay, and this will be 6.935 if you type into your calculator. Okay, last one on this page. Again, this one is a calculator problem, so you can look at all these curves on the calculator. Even though these graphs, you should hopefully be able to graph it by hand. I'm going to start with the cubic first. So y equals x cubed looks something like this. All right. Okay. Then y equals x plus 6. We're going to start at 6, right? And then we have a positive slope of 1 over 1. So again, it doesn't have to be exact. And then negative x over 2 starts at 0, 0, and it's a negative slope. So there's my region. Okay, let me make this a little bit bigger. So if you look at this graph, notice that the shaded region bounded by all three graphs is this in here, if you can see it. Okay, so again, I want to find the area of that yellow region. Let's go ahead and draw in a rectangle. This one you have to be a little bit careful. Notice if I draw this rectangle, it's always the red minus the blue. But notice if I go over here, the rectangle is now the red minus the pink. So notice the height of the rectangle changes. So that's how you know that you're going to actually need more than one integral. So notice I'm going to need this point right here. This point was negative 4, 2. This point right here is 0, 0. I'm going to find this point, and all these points we can find on the calculator. So notice as I move this rectangle over here, it's still pink, red minus the pink, but as soon as I get to 0 and I go over here, it goes red minus blue. So at 0 is where I need to split up this region. So I'm going to need to find the area of that little triangle and add it to the area of the other piece to the right of it. So from negative 4 to 0, the height of the rectangle is the red minus the pink, which is minus negative x over 2. So that'll give you the area of the triangle. And then the other piece, notice we're going from 0 to 2. And the height of the rectangle is the red, which is the line, minus the cubic function. So that would be that area. And if you add them together, you get the final. So at this point, we're just going to practice doing the setup. Don't worry about the integration.